So we're going to go through, okay, put your phones away now, put them away. I'm going to go through these problems carefully, and if you're watching on video, you should pause the video and analyze the code and write the answers before looking at the analysis that's going to be shown here. So this first one, we have this, these two variables that are initialized, x to 100 and total to 0, and they want to know how many times is the loop going to run for each of these cases. So let's write them in. So the first case is going to be x is going to be less than 100. And here you can see that x has been initialized to 100. So will this test ever pass? No. So how many times will the loop run? It will run 0 times. So let's put a 0 over here for this case. Now for the next case, we're just going to put an equal sign here. And we're going to ask, how many times will the loop run now? Initially, when we do the test, will the test pass? It will. And how many more times will the test pass? How many more times will the loop run? Yes, sir. Okay, you can see that x variable is being subtracted from here, so it's going to get smaller and smaller. And so this is always going to be true. And so therefore, this is going to run an infinite number of times. The third case we're going to look at is going to be for the situation where for which x is greater than 10. And so to do this now, you need to do a little bit of code tracing. And code tracing is kind of a personal thing. Everyone traces code differently. I'll show you how I would trace the code, but if you have another style for doing it which you're more comfortable with, it's fine. I like to draw columns here like this and basically say here's the total that's going to be added here, and here are the x values that are going to be considered. So when x is 100, x is going to start off at 100, and my question is, will the loop continue for that situation? It will. And so now we'll try it again for 90 and 80 and 70 and 60 and 50 and 40 and 30 and also 20. Now when we get to 20, we'll be here, 20 will be greater than 10. It'll come down here, it'll add in the 20, see that? And then it'll subtract 10 from 20, it'll get to 10. Will 10 be greater than 10? No. So you can see that the only time the loops are going to run are for these numbers here and not for the 10 or for the 0. So it looks like we're going to have to add up all these numbers to figure out what the output here is going to be for total. So we're just going to add up these numbers. I'm going to just take a little break away from computer science for 1 second and show you an easy way to add these numbers, because I'm guessing most of you are going to go 100 plus 90 is 190 plus 80. Most of you add like that, right? That's not a good way to add these numbers when there's a pattern. So I'll show you a little trick for adding them much faster. This will be useful to you in your life and also like places like the SAT where you need some speed. So one thing you want to do here is look for the pattern. So you can see that 120 make 120, and 90 and 30 make 120, and 80 and 40 and 70 and 50 all make 120. So how many of those green groups do we have? 4. 4. So you just go 120 times 4 is 480, and then this 60 doesn't have a partner, so you throw that in there, and you get 540, which is going to be the answer here. They want to know what will be the value of count, and they want to basically start off with the number at 20, and so once again, we can do some amount of code tracing here, and so here we'll have number, and here we'll have the count. And initially, we're going to start off, count's going to be 0, and the number is going to be 20. And we'll ask the question, is 20 greater than 0? And it is. And so then we'll divide number by 2. So number will be 10, and we'll add 1 to count, and count will be 1. Then we'll come back up to the top of the loop and ask, is 10 greater than 0? And it is. So number will decline to 5, and count will get to 2. And then we'll come up here and ask, is 5 greater than 0? And it is. So we'll divide it by 2. What will it be after I divide by 2 this time? Mr. Orspy, what will it be, sir? 2.5. Sir, it can't be 2.5 because you see number is an integer. it'll just be 2, and count will now be 3. And then when we come back over here, we'll see that 2 is still greater than 0, so then we'll divide again, and we'll get down to 1 here, and this will be 4. And then when we come back up, 1 will be greater than 0, and so we'll do it to 0 here, and then count will be 5. And then we'll finally come up here, and then number will be 0, so the loop will fail, and we'll come down here, and by the time we come down here, count will be a 5. Who can tell me the difference in the output between these two loops? Yes, Mr. Mason. There is none. These two loops are identical. This is question number 4. A lot of you asked me, hey, how come num was not initialized? So on the AP exam, you have to assume that variables that are not explicitly initialized have been initialized before. They've been declared and initialized. You just don't know what the value is. So we want to take this loop and rewrite it as a for loop. Just as a reminder, a for loop has 3 parts in its header. Oops, sorry. Let's try that again. For loop has 3 parts in its header. There's an initialization part here. And then there's something called a test. And then there's something called an increment here, like that. And then you have the body of the loop. And so now normally when we write for loops, we put the same variable, we initialize it, we test it, and we increment it. But there's nothing that says that it has to be the same variable. And here, for example, we see a case where it might be convenient to make it not the same variable. This initialization only runs once before the body of the loop gets started. This test runs at the beginning of each iteration. And if the test ever fails, then we exit the loop immediately. If the test passes, we do another iteration. And this increment, this is where most of the confusion comes in for loops. You can think of this increment statement. By the way, even though it says increment, you could put anything you want in there. It doesn't care. This line of code runs just before that closing curly bracket. It runs at the end of each iteration. So looking at this code, my first question is there anything we want to do only once before the loop starts? What is the thing we want to do? Mr. Deguj, what do we want to do, sir?
We want to declare an initialized total to 0.
Okay, so this part here, we're going to do for, and we're going to do int total equals 0. So that's going to be our initialization. Our test, how will our test for the for loop compare to the test for the while loop? That is correct. There is no difference in the test conditions. And now, what will be convenient to put at the end? What occurs at the end of this loop, at the end of each of the iterations of the loop? Ms. Ria? Okay, so we're going to use this as our increment. And for the body of the loop, we'll only have one statement, and that's going to be this total. So this is not the only answer, by the way. There are some other answers also, but this would be one equivalent for loop. Yes, miss? So if you put this over here, up here, and then did you just leave this part blank, or what did you do? That's actually okay. You still need that semicolon. Okay, but that will actually still be okay. It's kind of odd to do, but it's okay. All right, let's move on. And my first question is, what is this code trying to do? It's trying to do something. What's it trying to do? Yes, sir, what's it trying to do?
Count the amount of SIs in the string.
Okay, it's trying to count the number of SIs. Are there any bugs in it? No, it's perfectly good. And so what it's doing is it's looking for the first SI. So it finds this SI right here. Oops. It finds this SI right here. And when it finds that SI, it increments the result, which is just a counter. And then it moves the string pointer over 1 by the looks of it. But that's okay. It'll never match there on the I. So it just goes past here to that point. What is this index going to return if SI is not in the rest of the string? If I do an index of on a string and I'm looking for something, here I'm looking for SI, and it's not in there, what will this index of method return? Do you remember? So it would return a 0 if it was at the beginning of the string. So it needs to return a number that can't be a valid index. Do you remember what number that is?
-1.
It would return -1 when we're all finished. Right now, though, we're going to continue looking for the SIs. And how many SIs are in this string? 2. So that's what's going to print here. So here we have the word computer. I'm going to just rewrite it here a little bit bigger so we can work with it. And you can see it's counting down from 3. So you can see it's counting down from 3. So initially k is equal to 3. And what it's doing is that it's grabbing this many letters. So initially it grabs 3 letters. What are the first 3 letters that it grabs? Yes, miss? COM. So initially, if we're looking at the result variable here, result variable, it's going to grab the COM. Then the next time through the loop, k is now down to 2. K is down to 2. So it's going to grab 2 letters. So what's it going to grab? Yes, it grabs CO. And then the last time, actually I take that back. It looks like it goes includes the 0. So now it'll go and grab 1 letter. What letter is it going to grab? Yes, sir. C. And then it's going to run the loop one more time, and the substring is going to be 0, 0 here. And what I want to know is that going to cause a runtime error? What do you think, sir? No. It'll return an empty string. So basically, this will be the answer. There'll be an empty string at the end here, which won't impact this string at all. This is a similar code to what we saw before with the counting, except this time they're going through the string and parsing it and looking at the locations where the capital A is found. Can someone tell me what will be the output in this case? Okay, so the answer that they were looking for is 0, 5. And I was chatting with one of the TAs over lunch break, and he mentioned to me that if they had written this as a potential solution, given that it's a string, would that be correct or not as one of the right answers? Miss Tamara, what do you think?
No, because
There should be a space after the 5, so technically it should really be like that because there's a space after the 5. On this particular problem, they didn't try to trip you up on that, but they can get that tricky on the AP on rare occasions. Here, we are starting off with k equal to j. So initially, how many times is the word hello going to print? Let's look at it together. The first time it goes not at all, and then it prints one time. Let's see here. Prints 1, 2, 3. I think that's right, sir. It prints 6 times total. And then if we change the inner loop to be k equals j, and then set it to k less than 4, what's the first time through the outer loop? How many times is the inner loop going to run? Yes, sir. 4 times. So it's going to run 4 times, and then 3, then 2, then 1. So how many times will it run total? 10 times. So I think that the before was 6, and then the after is 10 times. Is that what everybody got? Okay. Let's keep going. So we want to draw this pattern, and we want to use a nested loop to do it. You can see that the item that's being printed here has to be the item in the outer loop here. And now the only question is, what should the inner loop pattern look like? Let's use a for loop. And once again, there's going to be more than one right answer, but let me just hear from someone I have not heard from yet. So I will be increasing. The first time through the loop, I is going to be 0. Second time through the loop, I will be going 0, 1. Okay, that looks like it would be right. Yeah, I think that's correct. Yes? Okay. Let's keep going here. This is the last one. And we have, this is very similar to one of the earlier questions where we keep dividing by 2. And the question is, how many times will this loop run? So here, once again, I'll trace through it. And so we'll just say a value over here, and we'll say the $ count over here. So first time through, a will be 100, and we'll print $1. And then the next time, we'll divide by 2, we'll get to 50. And the loop will pass there, and then 25, and then 12, and then 6, and then 3, and then 1. So when it gets to 1, the loop's going to fail. So it looks like it is 6. It'll only run for those. It won't run for the case where a is 1. So it looks like it's going to be 6. Is that right? Okay. Okay, so that's my little review for you on loop.